All right, so welcome to question 9. Question 9 starts off with a circular theorem question. Once again, if you're not familiar with circular theorems, just go to YouTube, type in iLoveLessons space circular, and the first thing that will come up is my video on circular theorems. That video explains everything in detail, but over here I just have a brief summary of all the rules here. So if you don't have the rules, pause the video, take down these 6 rules, and when you're finished, pause it one more time and take down rule 7. You mightn't need all of them for today's question, but it's handy for the future. So let's get started. In this question, they want you to find angle DBA. Now, just in case you don't know how to read the angles, DBA, you start from D, walk to B, and go to A, and it's always the middle letter. So in this one, they want us to find this angle here, that red angle. So to do this, we are going to actually use rule number 3. Rule number 3 says that if you have a diameter, and notice the dot here, which indicates the center of the circle, if you're going from here to the center to the other side, that's definitely the diameter. If you have an angle standing on the diameter and touching the circumference, this entire angle here, let me draw it in here, would be 90 degrees. So that from this corner here is 90 degrees. So if you know here is 46, then to find the missing portion, you just minus it from 90 degrees. So let's try that. 90 minus 46 is 44 degrees. So this angle here is 44. So the first answer is 44 degrees. And the reason you give to the examiner, you quote this rule and show the examiner that you minus the 46 from the 90. Great. Next one, angle DAC. DAC. That's this angle here. All right, angle DAC. Let's see if we can figure this out. Which rule would we use? I have a good feeling it's rule 1. Rule 1 says that if you have an arc, you notice the red one starts at the beginning of the arc, hits the circumference and bounces back to the end of the arc. The green one also starts at the beginning of the arc, but hits the circumference at a different point and bounces back to the end of the arc. It might be a little difficult to see the arc here. Sorry, it might be difficult to see this situation and this because of so many lines. But pay attention from here all the way to here. Let me see if I can put it in a darker color for you. Right, so this thick line, these lines are a little bit thicker. So that there is the arc that they are talking about. Now look at this. Starting at D, hitting the circumference at B and bouncing back to C. That's the end of the arc. That angle is 46. Here we have D again. It's going to hit A and bounce back to C, the end of the arc. So if here is 46, then this angle is also 46 due to rule 1. So here's 46 degrees. Right, and you just need to quote it for the examiner. All right, so I hope I had that correct, DAC. And the next one is BCE. B to C to E. Well, that's this guy here. All right, let's see if we can get this out. Now, I believe the answer for this one is 74. Let's see how we get to 74. Look at rule number 4 here. Here we have a cyclic quadrilateral. What they are trying to say is that the opposite angles in a cyclic quadrilateral always add up to 180. So look at the cyclic quadrilateral. Ignore the middle lines. A quadrilateral has 1, 2, 3, 4 sides. So that means this angle and this big angle here are opposite. This total angle is 46 plus the 28. So let me add that. 46 plus 28 will give us 74. So this big angle is 74. So that means if I add this angle and this one, I am supposed to get 180. So I have to minus 74 from 180 to get this angle. So let's do that. 180 minus 74. And this angle here will be 106. But they didn't ask us for this angle. They asked us for the one next to it. But remember, a straight line is 180 degrees. So if here is 106, how much again do we need to make 180? That would be 74 degrees. 106 plus the 74 will give us a total of 180. So BCE is 74 degrees. And I got that by using rule 4 and the fact that a straight line has 180 degrees. Alright, so let's clear this up and start the next part of the question. Alright, the next one is a straight out sine, tan, and cosine type of question, or the hard sine rule type of question. It's trigonometry. So I did a whole series on this. This is how you access it. iLoveLessons, space, trigonometry. The first set of videos that come up, you should probably look through all of them. I believe it's 9 videos and all. It goes through sine, tan, cosine, hard sine rule, hard cosine rule, even Pythagoras Theorem. So let's get started. Alright, so this was the diagram here. The first part of the question asks us to find PS. Now, I'm not too sure if you all remember this thing called alternating angles. It tells you that if you have two parallel lines and you slice them, this angle and this angle will be the same. Notice I have two parallel lines. They told us in the question it was parallel. So if here is 30, then this angle here is also 30. And they want us to find the length PS. So if I am standing inside this angle, this side is the opposite side, and this side is the hypotenuse, because the hypotenuse is always opposite the right angle. So sine is the only formula that has opposite and hypotenuse in it. If you are trying to find the opposite side, you block the O and you are left with hypotenuse multiplied by sine theta. Remember the hypotenuse, we are trying to find PS, which is the opposite side. So PS is equal to the hypotenuse multiplied by sine theta. The length of the hypotenuse is 8 and theta is the angle we are standing up in. Multiply this out and we will get 4 centimeters. So that means the distance from P to S is 4 centimeters. Great. They ask us in the next question to find PQ. PQ. You notice this is a right angle triangle. There are a couple ways to find this side. There are 3 or 4 ways, sorry. But I'm just going to use the easiest way. I'm going to use Pythagoras Theorem. Pythagoras Theorem states that it's for a right angle triangle. If we have the length of 2 sides, we can find the missing side using Pythagoras Theorem. Now, PQ is a regular side. To find the regular side, we take the hypotenuse squared and multiply it by side 1 squared and square root the answer. The hypotenuse is 8, so we say 8 squared minus the regular side given. Well, this wasn't given, we had to resolve it from the part above. So we're going to get 64 minus 16, that's 48. Square root of 48 is 6.93. So the length from here to here is 6.93. Alright, and I use Pythagoras Theorem. Great, let's move on to the next part of the question now. Let's put this over here. They ask us to find the area of the entire shape. Now, this here is a trapezium. Just in case you don't know the formula for the area of a trapezium, it's a half multiplied by the sum of the parallel sides multiplied by the vertical height. We know the vertical height is 4. We need the length of the parallel sides. We know from here to here 6.93, but we do not know the distance from S to R. So we're going to try to find from S to R. We know, so I'm just going to isolate this triangle. That's this triangle here. We know here is 8. We know here is 30. We know here is 82. It's very easy to reason out here is 68 degrees because all the angles in a triangle add up to 180. So we add these two and minus it from 180 to get 68. So we are actually going to use the hard sine, well, what I call the hard sine rule. That's this formula from my previous videos. So we are trying to find the length of Q, the parallel side. So in the hard sine rule, there are 3 letters. P in this one is R, S, and Q. You have to throw away one of them. The one we ended up throwing away is S because we had to find Q. So we kept the Q's and we have capital R and common R. So this is the hard sine rule for this particular triangle. I substitute in the values. R is 8. Capital R is 68. Common Q is what we are trying to find, and capital Q is 82. I found this on the calculator. I found sine 82 on the calculator. We cross multiplied and we solve for Q. So all the working is here. I'm not going to go through it in detail. So Q is 8.52. 8.52 is this length here. To find the area of the trapezium, it's a half multiplied by the sum of the parallel sides. So we have to add this and this. I have it here. And then multiply everything by 4. So we add the 2 and we work the whole thing out. And we get 30.9 centimeters squared. Right? I'm just double checking my answer to make sure everything is correct. Don't want to give you guys, yep, that is correct. Alright guys, so I really hope that you enjoyed this video, right? And of course, if you're rusty in your trigonometry, please don't forget to check it out on YouTube. Alright guys, the next question I'm going to be doing in my next video is question 8. Take care. And guys, don't forget to read the description below for this video. Thank you.